Hi there, and welcome to Intro to Meteorology, taught by your fellow Professor Susidrub. And basically, I'm starting these videos, and we're going to learn about the basics of meteorology. And this is on this channel, Book Bike. Um, Now we have to have some disclaimers, of course. And I'm going to say, not all images in this presentation are my own, nor the style and format of the lecture. It is based off of a different lecture. Under fair use, this is brought to you under the following conditions, which I will not read, but if you or any entity has an issue with this presentation in any way, please contact me via that email, and um, if there is an issue, I can take this video down. But this is purely meant to be informational. This video is not profited off of in any way, and all information in this video is accurate, unless I make a mistake, which in that case, please comment. All right, so let's start out, of course, the basics. What is meteorology? In case you don't know, which a lot of people don't, because, I've heard people mix it up with astrology or astronomy and a lot of different ologies somehow people mix it up with. But this is meteorology, and this is the study of the atmosphere and the processes that cause weather. And we are looking at the short-term stuff. On the other hand, if you were studying climatology, we're looking at the same things, but in the long-term climate, because climate is long-term. And we're looking at long-term averages, variability from those averages, extremes and frequencies of events. So if you were asked a question about like who would be interested in what, you would want to know what a meteorologist or a climatologist might be interested in. So, I mean, how often does it reach this temperature in September? That's going to be something that a climatologist is more interested in. But something like this approaching hurricane that we have currently when I'm making this video, of course, that's the short term. So meteorology. The National Weather Service is so super important because, and we're going to talk more about them later, but they are the only entity in the United States that is permitted to issue advisories, watches, and warnings. They are very important and are the most reliable source of information. Not saying that they're always right, but they are the most reliable, um, historically. And another thing is if you have ever wondered why that sometimes meteorologists are wrong, it's because in this day and age we actually don't have the technology and computer speeds to um get everything correct. We just don't know everything yet, and that's the reason. Let's talk about the atmosphere at first. We have to kind of build a foundation before we can get into the specifics of weather, okay? So, as you've probably learned before, we hopefully know the composition of the atmosphere. It's mostly made up of nitrogen, 78%. We have the next most abundant being oxygen, which is 21%. Um, as you may see, that only leaves 1%. After that, we have very small concentrations of other gases. But we have two types of gases in the atmosphere. We have the permanent gases that remain in a constant concentration everywhere, always. For the most part, oxygen and nitrogen are those that it's always that 78 and 21 for the most part. Of course, there's always some slight variability, um, but the variable gases, these are ones that can vary, and they're the most important for meteorology because depending on what their concentration is can affect what weather we may get. Um, we'll talk more about that later. So what happens as altitude increases? So altitude, hopefully you know what I'm talking about. I'm saying what's happening when we go up? As altitude increases, temperature should decrease. And, I don't know why, but I don't have a graph on here, which that would be very helpful. But if you saw a graph, you would see that it temperature decreases as you go up. And it's actually relatively a linear process. But that only lasts until we get to the top of the lowest layer of the atmosphere, which is the troposphere. Sorry. Um, that's the lowest layer, and the one above that is the stratosphere. In between that is something we call the tropopause. At that point, we have what's called an inversion. And what that means is that after that, actually temperature will increase. And above that, we that is not relevant for this lecture, but um, you do need to know that there's an inversion. We have something very interesting that happens at the top of the troposphere, and that is an inversion. And here's a side note. Um, why is it pretty freaking good that there's an inversion? Well, at this inversion, we're going to learn more about this later, but we actually, you know, as the severe weather that we get develops, we have air that rises, right? Well, once it gets to that point, it can't rise anymore. And, we get clouds right there. Okay. I mean, you can see this picture in the background that I took a few years ago, this thunderstorm right here. Um, the to be more general right now, as air rises, it can only get to a certain point. Um, and that's because of this inversion. But if it was able to go higher, that would not be good because storms would be way bigger and worse. We could have hail that could grow way bigger. It could even be the size of houses. Can you imagine that? Blocks of ice like that falling from the sky. That would not be good. So it just happens to be good. And another thing is that it's good that it's there, um, because, it helps us at this point get the temperatures that we need to survive as well. So that's good. Greenhouse gases. Some of our greenhouse gases are these variable gases that I talked about previously, and they include water vapor, carbon dioxide, methane, and ozone. Ozone is
That
real
feels
good
good.
because it kind of protects us from harmful levels of sun radiation. Hopefully you've heard about that. We have the ozone layer, which isn't the same thing as ozone, the gas itself, obviously, but we know the ozone layer includes that, obviously. So ozone is very important, but it also helps make the atmosphere warmer. So things in our atmosphere actually just happen to be the amounts that we need for survival. So that's good.
That feels good.
All right, yeah. Oh, ooh, okay. I don't know if you can see what just happened, but that wasn't so good. Um, all right, water vapor. This is our most important um gas that we have in the atmosphere. It is a greenhouse gas. It's variable. It could be anywhere from 0 to 4% by volume. So water vapor, obviously, we're going to talk about this more, but like that definitely affects weather. So CO2 is also a greenhouse gas. It's usually only about 0.038% of the atmosphere. How is it supplied? Well, you might know. Uh, from plant and animal respiration, decay of organic material, burning of fossil fuels, you hear that a lot, and even volcanic eruptions, but there's not volcanoes everywhere, so that's not as big of a part, but it's one thing. How do greenhouse gases affect global warming? So you know that they do, but do you know why they do? Well, the thing is, like, first of all, look at this graph. So we have been on the rise in the CO2 levels, and it's important to know what do greenhouse gases do. And the greenhouse gases actually, so here we're going to learn a lot more about this. But obviously the sun um emits energy to us, and then that is absorbed by the surface, but also reflected back. And that is actually the heat that we more respectively receive at the surface. And the greenhouse gases, um, when they're when they are in higher concentrations, that results in global warming because it affects. We're going to talk more about this, so I don't really want to get into it right now, but we're that affects their ability to the greenhouse gases when they're in higher concentrations, we have warming as a result, basically. And um, in the next lecture, we're going to talk about specifically why that is and what happens that would be the reason for that. So, aerosols, they're formed by both human and natural processes. This is also another one of those variable gases. They're very common in the atmosphere, and they can vary in size. Examples include dust, volcanic debris, sea spray, forest fire debris, and combustion. Now let's talk about pressure. Pressure is very important. What actually is it? It's the force exerted by the atmosphere on a certain area, and it occurs in all directions. Pressure is exerted every time that a molecule strikes an object, so that can help you see how like why it's a very abundant process. And it is super important because it affects so many other processes that create weather. And we're going to talk more about that. How does pressure change with altitude? Well, this graph is a little bit tricky for some to think about because it kind of seems backwards. But we're going to kind of just be like, all right, look, what's happening is altitude increases. Um, the pressure is decreasing. See, we had 900, now we have 100. And is it linear? No, it's actually exponential. Exponentially decreasing, that's not really a proper thing to say, but that's um, what happens. Common units of pressure, the most common that you'll see is MB, which stands for millibars. Um, and the average is considered 1013 by many. So if it's less if a pressure is less than 1013, we would consider that a low pressure. If it's more than that, we would consider it a high pressure. Usually it stays between 960 and 1050. Now we're going to talk specifically about like there's two different ways to look at pressure and that affects our measurement of it. It's also important to note that it's also can be measured in inches of mercury, but that is not used much anymore at all. All right, let's look at an ideal gas law. And basically, this is an equation that helps us see how pressure, temperature, and density of a gas are all related. You've probably seen this before, maybe if you took chemistry, but PV equals nRT. And what the letters stand for might be obvious to you, maybe other than the N and the R, but P pressure, V volume, N number of moles, R is a gas constant. So if you don't know what a constant is, that is something that is always the same. So R is always the same no matter what. Um, just like how pi is always the same, or um, E, other things that you see are always the same. T is temperature. Things on the same side decrease if the other increases, but they do the same thing on the opposite side. So if that doesn't make sense, what I'm basically saying is you might just know from algebra how equations work. So if I wanted to solve for P, then I would have to divide the V and it would be nRT over V, right? And if the V is bigger, if a bigger number in the denominator will result in a smaller number. So that means that if V increases, P will decrease. So if the volume is higher, the pressure decreases. But on the contrary, temperature, and we don't care about N and R right now. Like N and R are insignificant to what we're studying right now. But T is the opposite. So if I'm trying to um well once again, if I have nRT over V, if T increases, a bigger number in the numerator will mean that pressure will be bigger. So if the temperature increases, then the pressure will as well. So and this might make sense to you because you might know that as a storm is approaching, the pressure is dropping and the temperature usually drops as well. So temperature and pressure do the same thing, whereas pressure and volume don't do the same thing. They do reverse things. So that's probably the main thing to take away from this equation. You might have to solve it depending on what kind of class you would have, but we're not going to do that in this lecture. How does air move? This is really important. Air will always move from high pressure to low. So if you're looking at a weather map and you see H's and L's, that tells us where we have high and low pressure centers. And we would be able to tell which way that the wind is going to go. And it's always going to go from the H to the L. Why is that? Well, not just in weather, but you might know this by now, in almost all aspects of nature in general, equilibrium is attempted to be obtained. That's the way that our bodies work. That's the way our psychology works. That's the way almost everything in science works. Equilibrium. Things strive, systems strive for equilibrium. And that is the reason why that this happens. Needs, it moves when there's different pressures and it moves from high to low. Now I already mentioned we have two ways to measure pressure. That's atmospheric and sea level pressure. If we're looking at atmospheric pressure, which is not what we do in meteorology, we are looking at it as it's affected by altitude. I already said pressure is lower when altitude is higher, but can you see how that wouldn't be useful in meteorology? Then, of course, always the pressure is going to be lower in the mountainous regions or regions with hills, and it will be lower with places with valleys. So elevation would affect how we see weather, which is that's not useful. That's a confounding variable that we do not need. So what we look at is sea level pressure where everything is generalized. So we take that out of the equation. We don't care what the elevation is, what in general. So we're comparing apples to apples, as they would say, instead of apples to oranges. There's no point in comparing things that are different. They're always going to be different because of something. That's what the definition of a confounding variable is. So that's why it's not useful. So that's why we need to use sea level pressure. Lapse rate is how quickly temperature changes with height. Um, we'll talk more about this later on, but if something's getting if the temperature is getting colder or lower with height, we would have a negative lapse rate. If it's getting hotter with height, we have a positive lapse rate. All right, we're gonna look at weather maps now, but first, let's take a guess. Which of the following would you think would be a picture of a place in a high pressure system and low pressure system? Well, actually, haven't talked about it too much, but just take a guess. So the picture on the left would be that's not actually very good technically because you might not really be able to see that there's precipitation by that picture, but pretend like there is. Let's just say this is a hurricane. That's going to always be your low pressure systems. So low pressure systems are associated with precipitation. They can be associated with wind and bad weather. Um, but if it's higher, we're going to have clear days. So that's why the right one would be uh, high pressure system. It's going to be clear. Now, sometimes a lot of people will think, well, so the higher the better, the higher the pressure, the better. No. Not actually, because if the pressure was too high, we actually wouldn't be able to breathe. Um, so it can't be too high. But remember, I said 1013 is about the average. So if it's higher than 1013, we would consider that high pressure. And if it's lower, we consider it low pressure. And we're going to look more into this soon. All right. Oh, well, I already kind of referenced that. 1013. Um, Now, the following that I'm about to say, it's only true in the northern hemisphere. You might have learned already before, we have things like Coriolis effect, and things are different in the southern hemisphere than the northern, and that's just as a result of we know that. Well, first of all, we know, hopefully we have we're going to talk more about this in a different lecture. I've said that so many times, but um we have seasons and we have the Earth is on a tilt, so that really changes a lot of things. Um but what we're going to talk about is always going to usually be only true for the northern hemisphere. It's reversed for the southern. The reason why we're only looking at the northern is because we're mostly focusing on North American weather, specifically American. And also, weather is not as active in the southern hemisphere, and we'll talk about that too, why that is. Um, High pressure centers, I already said that's going to be where we have clear weather, we're going to have sinking air, and counterclockwise winds. It's the opposite in low pressure. We'll have cloudy weather, precipitation, maybe even storms. We're going to have rising air, and we're going to have counterclockwise winds. So counterclockwise is going to be how our hurricanes always spin, since that's going to be our low pressure center. Temperature, I don't think I really have to tell you what that is. That's hot or cold. But the main thing is that you're going to want to be aware that we have different units. You probably know this already, but we have Fahrenheit, we have Celsius, and we have Kelvin. Celsius is used I would say the most widely. Obviously, in America, we use Fahrenheit, but Celsius is used in Europe, and it's considered more standard. But we also like to use Kelvin sometimes, and we'll talk about why and how to convert between the two. Celsius and Kelvin are very easy to convert between, not as easy for Fahrenheit, but humidity is the amount of moisture that's in the atmosphere. So higher humidity, more moisture. Doesn't that make sense? If it's humid, you almost feel like the moisture in the air. But if it's arid, opposite. Um, wind, wind is interrelated with pressure. And first of all, what is wind? I already briefly mentioned this, but wind is essentially air being like, I don't like this. I'm going to try to make equilibrium. That's what wind is. It's the movement of air, and like I said, it always goes from high to low. We care about wind speed and wind direction. Fronts, you may have seen these on a map before. They are the boundaries between different types of air. So we have large air masses that are constantly shifting and shifting all around. We have wind doesn't always mean that it's a front coming in, obviously. But we have large air masses, and they're associated with our fronts. And these also have different types of clouds and precipitation and result in changes in temperature. Um, so here are our four main types. I'm not going to go into a lot of detail, but the top one is going to always be blue with triangles. Now, how come? Well, color is useful for people to see on the map, but we also have shapes because there are people that are colorblind. Um, and some things are just in black and white. So we have blue triangles, and that's going to always mean our cold front. Cold fronts are what's going to bring our rain, our precipitation, um, and we uh, will definitely have cloud cover when this is happening. And the triangles point the direction it's going. So if this was on the map, we would be like, it's going to the north. They're like, we're going this way. That's what they point. If you have the red circles, that's a warm front. Um, and these are going to bring dry air. It's going to be dry, and it's going to be warmer too. Temperature will typically drop when it's cold front. That's why it's called cold front. And we have a stationary front. Stationary fronts actually, as you might expect, don't do much, but they still will have rain oftentimes. Um, and then an occluded front, I'm not going to talk too much about this right now, but a occluded front sometimes can be associated with blizzards. Um, but they are pretty rare. You don't see those too often. So to recap, the cold front's kind of like muggy now, will be cooler and dry. The um warm front's gonna be like it's dry now and it's gonna be warmer and moist. Um, by the way, I said this presentation was based off of another. In the other presentation, it was mentioned how like some people don't like that word, so I apologize if you don't like MOIST. So, but unfortunately, kind of have to say that if you're talking about meteorology. All right, sorry about that. Kind of coming down with something over here. That's why I kind of might sound a little weird. Um, Station model. So we have this little thing right here. Have you ever seen this? Maybe not, because it's not typically on your everyday um forecast. But if you see this, what is the purpose of this? Well, this right here, these numbers and these symbols tell us so much about what the weather is like in this given location. Well, we're going to look at it. The top left is always going to be our temperature, luckily in Fahrenheit. So this would mean it's 76 degrees Fahrenheit. Those two little dots right there, they're telling us that it's raining. And if the dots can be anywhere from 1 to 4, 1, not raining that much, 4, it's raining hard. So this would be like kind of like steady rain, not super hard. They can also be symbols that look like asterisks. I don't know if that's the plural for asterisks, or is asterisk already plural? I don't know. Sorry about that. Not a um language guy, don't know too much about that, but whatever. If it's like that, that actually means snow. So it can be um the little snowflake symbol. This 55 down here is our dew point, and this reflects the amount of moisture. This flag right here, the line extending, is our wind speed and wind direction. Now, what I'm about to say is really important. Winds are always named from where they come from. And this thing is also showing where it's coming from, not where it's going to. So it's coming from the northeast. So we call this a northeasterly wind. So don't think about it like this is like one of those things you see at an airport and oh, it's blowing to the northeast. No, it's coming from the northeast. So coming from, coming from, coming from. Always remember that. Easy to mix up. And so I just told you how you can know the direction. How can you know the speed? Well, if you see that there's two, you don't need to know the specifics right now, but if you see the two flags on it, well, that's telling us the amount of the knots of wind. So the longer it is, the more. You could even have a triangle right there. You could have shorter ones, but that's not what we need to know yet. This orange one's really important too, pressure. But you might be looking at that and thinking, well, I thought you said usually the pressure is between 960 and 1050. It is. So the pressure is not 138 MB if you looked at this. You have to do a little something. I guess they didn't want to put four numbers on here because for one thing, if we only round to the ones, that's not as accurate as if we could use a decimal point. That's one good reason. Another is we can have less digits on a map, which is results in less clutter. So they only ever do 3 digits, which you're going to have to add one to the beginning and then put a decimal in. So we're going to add a 9 or a 10 because we're not going to get things in the 800s or the 1100s. But how do you know if you add a 9 or a 10? Well, there's a way you can remember it, like based on what numbers there are. So, but you can also just put the number on there and see what makes sense. All right, I'll put a 9 there. So now we have 9138. Well, that still doesn't make sense. You always have to add a decimal between the second to last and last number. So now we have 913.8. That doesn't make sense. Pressures are not that low, typically. Like that's going to be an anomaly if that happens. So 913, I said it doesn't go below 960. Well, it can. Definitely in hurricanes it can, but 913 is not going to be something that we would expect. So we'll put a 10 there instead. Now we have 1013.8. Yeah, that makes sense because I said that's about the average. So that's what you have to do. You have to add a 9 or a 10. So the rule is going to be if the first digit's between um 1 and 5, or actually sorry, 0 and 5, it's going to be a 10. If it's 6, 7, 8, or 9, then you're going to add a 9. And if you don't want to remember that, then just put the number there and see what makes sense. If this said if this said 938, then if I put a 10 there, it doesn't make sense because 1093.8, too high of a pressure. We can't go higher than 1050 usually. So put a 9 there. Okay, 993. That does make sense. All right, this yellow is telling us how pressure is changing. Right now, I'm not going to explain specifically what that means, but that's what you just need to know about that. Last thing is this circle. Oh, last thing is that circle. That's telling us the cloud cover. Since it's completely colored in, that means overcast completely. But if it was only halfway, then obviously it's like partly cloudy. If it's white, then it's clear. But you couldn't have a white and then these two dots right here. Doesn't that make sense? We couldn't have rain and it be clear. Okay, so here's a map from so today when I'm making this video, it's September 25th. Why does this say September 26th then? And yeah, sorry if you're watching this like way after this got made, but still relevant. Why does this say September 26th? Because everything on these maps, by the way, this is NOAA that this came from, but the National Weather Service is under that. And they always go by Greenwich time. And if you don't know where Greenwich is, it's in England and it's always 5 hours ahead of Eastern time. So you might not be in the Eastern time zone, but you could hopefully calculate from there. But I am in this Eastern time zone, and so I always see what this is, and then I'm saying this is 5 hours ahead of from what it is. Well, we see OOOOZ. So that's saying midnight. So this was from midnight in Greenwich. So that's 5 hours ahead. So that means 7 p.m. where I am. This is from 7 p.m. So outdated by a few hours when I made this video. Um, but we see a lot of the stuff that I just talked about in here. A lot of crazy numbers and stuff. Now what does that mean? It can be a little bit overwhelming, but let's just look over here at this one that's out in the ocean. It's easier to see. And luckily they color coordinated the different numbers, so if it's hard for you to tell. The reds are the temperatures, so it's 80. Ooh, pretty warm, right? Kind of warm for this time of year. We have a dew point of 76. 142. What pressure do we have right there? That's going to be 1014.2. So that's a pretty average pressure. It's not really high or low. And the H's and L's are telling us if it's higher, the high and low pressure areas. Down here we have a hurricane, Hurricane Helene, that's about to hit Florida, so be safe. But it's kind of hard to see because this isn't like a person that like placed all of these labels. Like, so some of them are blocked. But right there, I can't see exactly what that number is. I see a 6 and a 2, so it's hard for me to know what that is. Um, I guess that's 62. Um, yeah, I think that's a 6 and a 2. So 62. Then what do we see here? It's hard to see, but I think that's a 220. Um, Now I told you pressures um usually can't go below 960, but they certainly can with hurricanes. Now I don't think that's a 922 pressure. I don't think it's that low. Um, but we let's also look at these winds. So you these can help us know the way that the wind's flowing. So I see right here they kind of look a little bit random, right? Because it's over here, if you had a bunch right here, it would be like not this way, but this way. It's going counterclockwise. That's the way that these always go. Over here, though, it's kind of just random, especially out here. But we have some stationary fronts, a lot of stationary fronts. And I say that they don't do much, but I actually right here, I'm around right here. I'm actually getting a lot of heavy rain, not as much now, but there's even been some uh tornado warnings issued around here. So that doesn't mean there's going to be nothing. And over here we have an included front that I was talking about. We have a cold front right here. So what's this saying? We're saying it's going this way. And then these brown lines are what we call so ISO means the same, and these are isobars. So isobars are equal lines of pressure, and on these equal lines of pressure, we can tell, we know, I already said, it's going to move from high to low pressure. And that's what's going to happen all over the place right here. Um, so sorry that I stayed on that for such a long time, but it was relevant. Advisories, watches, and warnings. Right now, this is currently very important for you to know if you are anywhere in the southeastern United States. Advisory is low urgency, but it's just something to be aware of that may cause inconvenience. It's not nothing, but it's not something, if you get like a winter weather advisory, that's not going to be the end of the world. A weather watch is saying, look out, a significant weather event may happen within the next day. So if you get a tornado watch, it does not mean that there is a tornado right now. It is saying the conditions are very favorable for a tornado to happen soon, within the next 24 hours. Um, a warning means that it is happening now or in the very near future. So a warning is when that's the highest urgency. Well, look at what we have right now. The whole entire states of Florida, Georgia, and South Carolina are all under some form of watch or warning. What is this dark red? Um, the dark red is um tropical storm warning. So what that means is that these places are going to experience, it's almost certain that they're going to experience tropical storm conditions within the next 24 hours, probably 24 to 48 hours. Um, and the red that's just slightly lighter is a hurricane warning. They only extend to here because they probably think like after here it's going to be tropical storm. Um, we have purple, that's storm surge warning. Storm surge, basically, what is a surge? The surge is like the water is being pushed so hard that it's going to surge. It doesn't mean that there's flooding from rain. It means that from the wind, the water is all being pushed at once and it's going to surge, like on to the land. And it could be several feet of water going not where it should be. But you can see this is going to be a significant storm because we have things already extended way up here. Tropical storm, even in North Carolina. And then up here, we already have flash flood watches and warnings. See this red right here? It's kind of, in my opinion, there's only so many colors, but like it's very similar color to the um I actually think that I might have my colors a little bit off because I don't think I guess my cones are can ha see as many colors basically. So to me this looks very close to that color. But it's not the same thing. That is a flash flood warning. Here's a different way we can look at it. Well, here's what it always is going to look like for our tropical systems. Right here, we're saying that right now it is a hurricane. M means it's going to be a major hurricane. So it will be, right now, is expected to be a category 4 when it hits Florida. This white is what we call our cone of uncertainty. So we're saying like, okay, within this cone, it's gonna hit here, and as the models get more and more accurate, that can narrow so we know exactly where it's gonna hit. Because just a couple days ago, this cone was a bit wider, but now it's more concentrated because the models have become more organized and in agreement with one another. But we're gonna go right here. It's still gonna be a hurricane when it gets here. It's gonna be a tropical storm when it's here, and then depression, it will dissipate. But it's going to move really fast. As you can see, Saturday, it's already going to be way up here. And 7 p.m. Wednesday, this is where it was a few hours ago. Um, so they take these things seriously. We have tropical storm uh, warning. Well, I already showed you it's for the whole state, but right, we're just looking at the coastline on this map. Um, all the way over here, even though this isn't where it's going. Um, and it can be a state by state thing because as you can see, it just stops at the state line right there. But um, this cone doesn't mean that there's going to be nothing over here or here. There's going to be bad weather, worse on the east side of it than the west. So there's got a lot to be concerned about over here. So obviously this was only supposed to be an intro video, and I nerded out on this thing, but it tells you that how important the National Weather Service is because they are the only ones that can issue these things. And these things can really be life or death situations. This is going to be like one of the worst, if not the worst, hurricanes of 2024. Hurricanes like this happen almost every year. But anyways, that's it for this video. Thank you for watching. I hope that gave you a good introduction.